In this video we are going to see how frequency, phase and sampling time will affect a graph. So I have this HTML application. I will share the link of this application in the description. So here we have three parameters: frequency, phase and sampling time. We can change and see how it affects the graph. So for example, frequency, and this part which is moving, the 6.66.67 cos and something, that is the equation of the graph. So for example, if this frequency is 0.05, the equation would be cos 2 pi f, where that is this frequency plus phase. We have phase 0, so no additional part it shows, and this is sampling time, which I will show you later. And then the 66.67 is amplitude that I have chosen to be constant, so we don't have any way to change it, but that will not have much impact. Mostly these three parameters are important for us for this video. So for example, frequency, if I remove a 0, so now I have a graph of higher frequency. So as you can see, more number of cycles per unit time. Okay, and I have these buttons next to it, increase by, so you can assign some value, how much you want to increase, and then how many times you want to do that. Suppose I want to increase the frequency by 0.01 and do it 20 times, so I can put these values and then click on run. So it will show me how it will affect the graph. If you want to do the reverse, we can do a minus sign and run. We'll do the reverse of that. Same goes with phase. If I remove the phase value from 0 to something like 118, it will do the change. And if I change the increase by say 0.5 and do it 200 times and run, so it will show what is the impact of phase change over time. Now the sampling frequency. See, currently the sampling time is 1 second. So every second a sample from this graph has been taken. That's why we are seeing it as almost continuous. Now if we increase it by let's say from 1 to 10, so see, now if we have very few samples of per cycle, if we increase it more, say 16, we have even lesser samples, 19, even lesser, like that we can do. If you want to see a continuous change in value, we can give some values, like let's say I want to increase it by 0.5 and do it 100 times. So I will do change these values and I will run. See, as the sampling time increases, the graph will respond to it. And meanwhile, you might have noticed this thing, that our equation also changes as the other parameters change. So now I have the phase as 118.5, and this one, yeah. So the phase, as you can see, I have phase as 118.5, but here you are seeing it as 37.72 pi. So it's actually converting it in the form of pi. It is dividing the phase by pi and then showing the result. So 118.5 by pi will be 37.72. That's why 37.72 pi. Okay, now we will see few cases. Like for example, if I increase the frequency, see, the equation is 2 pi f. So if I increase the frequency by 1, we should not be able to see any change in the graph. Why? Because that is equivalent to adding 2 pi to the graph, and 2 pi added to a cosine will not change. So if I do that, I have frequency 0.05 and I am increasing the frequency by 1 every time. So if I run it 20 times, see, frequency changed to 21.005, but we didn't see any change in the graph. Now if you want to if you suspect this thing, I will just add a little bit to it. I will add 1.1, and now if I run, you can see the changes, but with 1 you won't be able to see any change. Okay, so say if I have 0.01 and I run, it changes. I refresh it back, change the increase by value to 1 and run, I see no change. Same thing we can try with the phase also. See, if we increase the phase by pi, so I mean 2 pi, the graph should not have any impact, and pi is equal to 3.14 almost, so 2 pi is 6.28. See, for pi is not exactly equal to 6.28, so we will, in this case we will see some movement, because earlier in case of frequency we are just providing here by 1 and the equation sorts it out, so their actual value pi is being taken. Here we don't have any way to, from the UI we don't have any way to provide a pi value, so we are giving the approx value, that is 6.28. so we'll see some little bit of movement, so that says 6.28, and if I run it, see, you can see, you might not have noticed, let me increase the number of count by more, so it will run 200 times now. So if I run, so you can see little bit of movement, that because of the error from pi this value has. So this thing, these were the few things. Now if you want to try few more things in this, the file will be available in the description, you can download it and try, and if you have any queries you may post it in the comment section. Thanks.